Okay, it's recording now. Okay, so hi everybody. Welcome to the first Math Kangaroo class. And today we'll just cover the 2014 Math Kangaroo. So the competition will be on March 18th, 2021, which is in a few weeks. And until then, we'll be covering all of the competitions from 2014 to 2019. And I planned on doing the 5th to 6th grade competitions, so the Benjamin level. I'd like to ask, what grades are all of you in? Just type it in the chat. Oh. Okay, so, and then Colin is in 5th grade. So, so 5th to 6th grade might be a little hard. I could lower it down to 3 to 4th grade. Would that be good? Because 5th to 6th grade would be too hard for some of you. Okay then, so let's just open up the 3 to 4th grade competition. And in this class, we'll try to do the last 10 questions, starting from the last question, which is 24. And we'll keep going until we run out of time. So, let me share my screen. So here's the competition, and it has 24 questions total. This is the 3 to 4th grade. And let's start at problem 24. So Albin has put each of the digits from 1 to 9 in the field of the table. In the diagram, only 4 of these digits are visible. For the field containing the number 5, Albin noticed that the sum of the numbers in the neighboring fields is 13. He noticed exactly the same for the field containing the digit 6. Which digit has Albin written in the gray field? So let me first open up a blank board. Wait, not yet. So there are 9 numbers total in this 3x3 grid, and there are 2 numbers that we're looking specifically for, 5 and 6. And for all of those, the numbers that all surround it are 13, sum to 13, that are neighboring. So let's see if we can figure this out. Let's first take 5 and then find all the places that we can put it in. There's this place, the left, the right, the top, the bottom, and the center. So let me draw this on a whiteboard. So you have a box here, and you draw these lines to place the numbers in. And then we have 1 here, 2 here, 3 here, and 4. Now, if we look for 5, let's find the places where we could put it. If we put 5 right here, if we put 5 here, and all the surrounding numbers sum to 13, that means that 1 plus 4 plus whatever is in the center box is equal to 13. So this must be 8. That's our idea of what we are going to do. And then if we take a look at where 6 could be, we can look at all 3 of these places. If 6 were here, you'd have 1 plus 8 plus 2 is equal to 11, which isn't 13. And it says that the numbers that are connected to the number 6 have to be 13. So we can't do that. Now, so we first remove this 6. Then if we put the 6 here, we find that 2 plus 3 plus 8 is equal to 13. So we can do that. And now we already have the places where the things should go. So the middle box, which is the shaded in box, should be 8, which is D. So for this question, all you had to do is just try different places where you could put the numbers 5 and 6. And it's just guess and check, and then you can get the answer correct. So this problem wasn't too hard. Okay, so I'll clear this, and let's move on to question 23. Figure on the right, the small squares will be painted gray. I think someone is unmuted. Could you please mute yourself? Thank you. Okay, so on the figure on the right, a few of the small squares will be painted gray. In doing so, no square that looks like this is made from 4 small painted gray squares must appear. At most, how many of the squares in the figure can be painted gray? So here, we could try guess and check again. But let's do this at a more tactical approach. What you want to do is to avoid making this kind of arrangement. And the most you could do is, I'll just put a check mark where you would have check marks going. No. Okay, so this isn't letting me annotate. So what I will do is I'll go back to the whiteboard and draw this. So you have set. Okay, so I'll draw this. Here's the wide one. Here's the tall one. And this is pretty, and yes, this is the diagram that they're looking for. So here we're trying to avoid getting this situation where we have 4 squares that all have a check mark in them. So it looks like this. If it looks like this, that's what we don't want. What we can do, however, is to have these. This way, we can avoid as many 2x2 boxes as we can. So let's just fill these in random ways. So we can try this. We can put one here. We can put one here, here. We just want as many check marks as we can without making this sort of pattern. And you can basically just draw in randomly. So here's just a demonstration. I just filled in whatever I wanted. And however, if you had a square here, this square actually has a 2x2, which is equal to this, which is what we don't want. So let's remove that. Let's remove these 2 check marks. And if we look around, there doesn't seem to be any check marks. If it's not exactly clear, let me draw the check where there aren't check marks. 1, 2, 3, 4, 5, 6. And let's look around if we can add any more check marks. It doesn't seem like we can, but however, you can have more check marks than this. So let me clear all these. Now, this time let's try something that isn't randomly placing check marks. So let's try this time by filling in everything with a check mark and see if we can figure out the least amount of check marks that we can remove, which is equal to the number of squares filled in. So let's find the essentials that we have to remove. This part is okay. You can't have any 2x2 squares, but we can remove this and you won't have any 2x2 squares here or here. However, we have 2x2 squares here and here. So let's see if we can remove one here. If we remove this one, then this is safe, but this isn't. This has a 2x2 square. So We have 2 by 2 squares here, here, and here, and here. Let's try to find the least amount that we can remove so that we can do this. The darkest spots are where the most squares overlap, so let's find the darkest spot we have here. Let's remove that check mark. Okay, but this check mark, this box still has a check mark left. So we can remove that. And now this is our situation. Let's fill in the places that don't have check marks with a question mark. 1, 2, 3, and 4. These 4 parts, and then we look around. Are there any 2 by 2 squares? Yes, there are. There is one here. So we could try removing one more, or we could do something else. We remove this question mark, replace it with a check mark here. Then now we have 2 2 by 2 boxes. Well, we can remove both of those by taking out this check mark. And so we have only 4 check marks removed, and everything else is a question mark. And if you look around, there are no 2 by 2 squares, so that's what we'll do for this question. There are 4 boxes that are not shaded in, so the total number of squares, which is equal to 25. Yes, the total number of squares is equal to 25, and we have 4 removed, so the answer to 23 is D. Now let's make a list on the whiteboard. So 24 is, what was it before? It was 8, so 24 is D. And then 23 is D again. So now let's move on to problem 22. So in each box, exactly one of the digits 0, 1, 2, 3, 4, 5, and 6 is to be written. Each digit will only be used once, and which digit has to be written in the gray box so that the sum is correct. So here we have a 2-digit number plus another 2-digit number is equal to a 3-digit number, and we have to use 0, 1, 2, 3, 4, 5, and 6 only once. So let's figure out how we can do this. What we attack first is we first draw a diagram, which is very useful if you want to do good in these questions. Draw as many diagrams as you can so you can visualize the questions. That'll make everything a lot easier. Okay, so we have a square here, 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 here. And this is similar to this diagram, except we can edit it. And this is just a plus. So let's look at the hundreds digit. If we have two two-digit numbers adding together, what is the maximum that we can have? If we have 99 plus 99, then the highest number that we can have is 198, which shows you that the 100 digit can only be 1. If you have something that starts with 200, you can't have two two-digit numbers that add up to it. The largest two two-digit numbers don't add up to it. They only add up to 199, which proves that the front can only be either 0 or 1. Okay. So let's see if we can figure out some more. Let's just say it's equal to 1. So you have 2-digit number plus 2-digit number is equal to 100 something. Let's just fill in random numbers. We have 1, 2, 3, 4, 5, 6, and 0. So the tens digits, if you have 4 plus 5, that won't work because, let's just try this. 4 and then 5. So here we have 1, 2, 3, 4, 5, 6, and 0. That is our number bank. We now have 1 removed, 4 removed, and 5 removed. So 2, 3, 6, 0. Those are the ones we have left. Now, if we get our second largest numbers, 3 and 6, it doesn't matter which two-digit number we put on. They're still adding together the same way. This only adds to 99, which isn't big enough. So we have to remove this 4, and we could replace it with a 6. So 5, and then let's edit our number bank. We have 2, 3, 4, and 0. Let's see if we can add something together. If we have 2, 3, then this adds up to 5, and this adds up to 11, because 6 plus 5 is equal to 11, and we can't repeat that. So even if we use 1 here, and 6 plus 5 are the largest, we get 114, which is not possible for this. 115. But 2 plus 3 does not equal to 4, so that's more proof that we can't use 1 as the hundredths digit. So let's remove that. We now have 0 as the hundredths digit. And let's edit the number bank so that we have 1, 2, 3, 4, 5, 6. No 0. Now we can't have the tens digits adding up to greater than 10, because then that would mean a 1 in the hundredths digit, which we have already tried and it does not work. So let's try putting 1 and 5, and that adds to 6. We now have that, and what we have left are 2, 3, and 4. And obviously you can't have 2 and 3 add to 4, or 2 and 4 add to 3. So let's clear this and try again. Now we can try 2, we can try 1, 3, and 4, and then we can try, let's remake the number bank. So we have 2, 5, and 6. 2 and plus 5 does not equal 6, so we can't try that. Now let's look at, let's just look at 10 digits that add to each other. We can have 12 plus 34 is equal 12 plus 13 plus 24, or 42, is equal to 55. We can't do that. We can have 14 plus 32 is equal to 46, which uses up 2 twice. So it looks like we still can't use the tens digits. Let's try some more. So 24 plus 36, nope. 25 plus 36. And here we have something interesting. We have 25 plus 36 is equal to 61. That still doesn't work, because we haven't used 4 yet. So let's see if we can look back to using 1 as a hundredths digit. So now we have 0, 0, 2, 3, 4, 5, 6. So we can have 24. We need to have it add up to greater than 100. So we've already tried 40 something plus 50 something, and 50 something plus 60 something. We can now try 40 something plus 60 something. Let's try that. So 4, 4, and 6. Now what we have left is 2, 3, and 5. And that adds up perfectly. We can have 2, we can have 3, and we can have 5. And if we finish this calculation, 42 plus 63 equals 1 blank 5. The number left over is 0. So let's check that with the calculator. So the calculator. 63 plus 42, and 63 plus 42, and we check that, we get 105. And that uses all the digits 1, 2, 3, 4, 5, 6, and 0. So now we can go back to the questions. Now that we have 22 done, let's write down the answer. We have 42 plus 63. Let's write down that answer. So 22 is equal to 42 plus 63, so 105. And 5 is in the ones digit of the sum, so D is the answer. Okay, now let's go to 21. Heinzie the kangaroo has bought some toys. For this, he gave 150 Kangaroo coins, KC, and received 20 Kangaroo coins back. Just before leaving the shop, he changed his mind and exchanged one of the toys he had bought with another one. Therefore, he received a further 5 Kangaroo coins back from the shopkeeper. Which of the toys in the picture has Kangaroo taken home with him? So he spent 150 coins and received 20 back. Then he changed his mind and bought and exchanged one of the toys with another one. So originally he had spent 130 coins on a few toys. Let's see which toys add up to 130. Let me first clear the previous question stuff. So we have 150 minus 20 is equal to 130 coins spent. Then let's look at the number of objects that he could buy. So there's 40, 73, 52, 48, and 57. Let's write these down. 40, 73, 52, 52, 48, and 57. So those are the things, and we have to find a combination that adds up to 130. So we could try these in order. So 40 plus 73 is equal to 113, which is not equal to 130. And we can keep trying this until we find 73 plus 57 is equal to 130. That is the right one, so we could use this. And yes, so 73 plus 57 equals 130. Those are the toys that he bought. So he bought the car and he bought the train. Then he exchanged one of the toys with the shopkeeper because he changed his mind, and they received 5 more coins back. So he exchanged a toy and got 5 coins back. And that means that the toy that he exchanged for was 5 coins less. And we already have 73 and 57. So we just find a number that is 5 coins less than either of these. 5 coins less than 73 is equal to 68, and that's not on the list. But 5 coins less than 57 is 52, which is on the list here. So, which of the toys in the picture has Heinze taken home with him? He has taken home the 73 coin one and the 52 coin one. So 73 is the carriage and 52 is the plane. So the answer for number 21 is A. This one you can just guess and check again, or you can use a different strategy where you total the number of coins that he did choose, and then that is your answer. So 21 is A. Okay, so 20. The number of black diamonds and white diamonds follows a fixed system. In the picture, the first 3 levels are shown. Each level has 1 row more than the level before. For each level, the following applies. In the last row, both of the outermost diamonds are white, all the other diamonds are black. How many black diamonds are there in level 6? So let's first count up how many total diamonds there are in each. So for level 1, there is 1 black diamond and 2 white diamonds. 1B and 2W. And there's always going to be 2 white diamonds, so we'll just write the number of black diamonds. For number 2, there are 4 black diamonds. So let's write that down. 4B and just 4 black diamonds. And then number 3, we can count these up. There are 8 diamonds. So we'll have 3 is 8 diamonds. And we can try drawing another pyramid. So this is 1. We'll do check for the black diamond and X for the white diamond. Here's 2. And here's 3. And then we have the black diamonds here. And we can just try drawing the 4th layer. So you have 1, 2, 3, 4, 5, 6, 7, 8. And we can see that these are all layers of triangles. So the first triangle has 2 layers, the second triangle has 3, third triangle has 4, and the 4th triangle should have 5 layers. So this is 1, 2, 3, 4, 5. So we accidentally went 1 layer too much, so let's remove these 2 bottom ones. And let's put an X in the others. So let's count up the number of checks here. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13. So we have 13 here. And that does not look like a very good pattern. So we only have 10 minutes left, so I'll try to rush up this meeting, so this question. So this doesn't look like a good pattern to figure out. So let's try the total number of diamonds. The first one has 3, the second one has 6, the third one has 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. The 4th one has 13 plus 2 is equal to 15. And if we look at the differences between these, this is a rather tough pattern to find, but if you look at these, distances between these are 3, 4, 5, and it just keeps increasing. So we can look at the next one and say that is confidently 21. So how many black diamonds are there in level 6? This is level 1, 2, 3, 4, 5. And if we add 7 to 21, we get 28. So 28 is the total number of diamonds, but there are always 2 white diamonds. If we subtract 2 from 28, we get 26 black diamonds. And 26 is one of the answer choices, and it is C. Okay, so we don't have much time left, so here's what we'll do. Let's first review our answers. So with 2014 answers and 2014 questions. So For number 24, the answer is D. For number 23, the answer is D, which is what we got. For number 22, the answer is also D. 21 is A, and 20 is C. So we got all 5 of these questions correct. Okay, so let's stop the questions now, and we could continue this next time, or we could do the next year's problems. So, and for homework, I will choose. We have these 5 questions. I'll make different versions of these questions, which I'll distribute to you through a Google document. Okay, so, and then those questions will be due by next class, where we'll share what answers we got for the questions. And that's about it. So we did these five questions, and they're all pretty tough questions, but by using the right strategies, for 24 is just guess and check. For 23, we could fill in and then take out checks. 22, we could also guess and check. 21, we found the sum of the coins that Heinze spent. And for 20, we found the total number of coins through an interesting pattern. And then we used the total number of coins to find the number of black diamonds. So that's what we did today. And then I'll see you guys next week. Bye.
Thanks. Bye.
Bye, have a nice time.
Bye.